Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. Dipole moment depends on vector addition of bond dipoles in CIS versus trans isomers. Melting point, trans isomers are more symmetric, pack better in crystal lattice, so trans generally has higher melting point than CIS. Boiling point, CIS isomers generally have higher dipole moments for most substituents, leading to stronger intermolecular forces and higher boiling points than trans. Moving on to the next step. H3C, CH is equal to CH, CH3. To butene, both substituents on each carbon are the same type, CH3 on one side, H on the other for each sp2 carbon. In the CIS isomer, the two CH3 groups are on the same side, giving a net dipole, small but non-zero due to hyperconjugation induction. In the trans isomer, the molecule has a center of symmetry, so dipole is equal to 0. Therefore dipole CIS trans P. Trans 2-butene is more symmetric, so melting point trans CIS R. Since CIS has higher dipole, boiling point CIS trans S. So A matches P R S. B H3C CH is equal to CHCN, but to N-nitrile crotononitrile CH3 donates electrons, CN withdraws electrons. In the CIS isomer, CH3 and CN are on the same side, their dipoles partially cancel, CH3 pushes toward double bond, CN pulls away from double bond, and in CIS configuration the vectors partially oppose each other more. In the trans isomer, CH3 and CN are on opposite sides, and since they pull in opposite directions along the chain but the geometry means their contributions add rather than cancel, trans has a larger net dipole. Thus dipole, trans CIS, Q. Trans is more symmetric in terms of shape, so melting point, trans CIS, R. So, B matches Q, R. C, H3C, CH is equal to CHCl, 1 chloropropene but 1 N. Actually 1 chloro, 2 butene CH3 is electron donating, Cl is electron withdrawing. Similar to CN case, in the trans isomer the opposing groups, CH3 on one carbon, Cl on the other, create a larger net dipole than in the CIS isomer where partial cancellation occurs. Thus dipole, trans CIS, Q. Trans has higher melting point, R. So, C matches Q, R. D. ClCH is equal to CHCl, 1, 2 dichlorothene both substituents are identical, Cl. In the CIS isomer, both Cl atoms are on the same side, so their dipoles add up, giving a large net dipole. In the trans isomer, the molecule has a center of symmetry, so dipole is equal to 0. Therefore dipole CIS trans P. Trans is more symmetric, so melting point trans CIS R. Since CIS has higher dipole, boiling point CIS trans S. So D matches P R S. And for the final step, A P R S B Q R C Q R D P R S. Therefore, the correct answer is A P R S B Q R C Q R D P R S. Therefore, the correct matching is A matches P R S, B matches Q R, C matches Q R, D matches P R S.